Hello and welcome to Intro to C. I'm Bill, and today's episode we're going to learn about the basic data types built into C. So in the previous episode we learned about variables, how to declare them and actually assign to them, but we only used int, an integer type. Now C has kind of 5 basic built-in types that we can use, and there are variations upon these types as well, which we can use with type like qualifiers as well. So the basic types are char, int, float, and double, and the new C99 standard also adds bool into that equation as well. And note it has an underscore and a capital letter. All these basic types are all lowercase except for bool, but that has a reason for it. I'll talk about that later. And they all have different uses. So a char is a type which is capable of holding one character in the local character set. So that may sound confusing, but what it means, it can store a character, a letter, a number, a symbol. That's what it's big enough to store that on your local character set. So on your American keyboard character set, you'll have A to Z and all that. Look up ASCII if you want to learn what you can do on there. If you're on a Japanese computer, this isn't the case. Depending on what Japanese computer you use, a char isn't capable of holding your characters. So, again, a bit confusing. Don't worry, I won't go into too much detail now. Computers are complicated things. Int is an integer. You can probably guess that, which is a whole number, a number without a fractional part. Now, this is typically the natural size of integers on the host machine. So, again, that's a bit confusing, but from the standard, an int is a certain size. That's all you need to worry about. Yeah? A float is a single precision floating point number, and a double is a double precision floating point number. Now, you may think, what the hell's a floating point number now? Okay. So it's a way of storing real numbers on your computer. So a real number is from the mathematical sense, in that it can have an integer part and a fractional part. So a real number in this sense is 123.456. That's an integer. So it has a integer part and then a fractional part. Because these are only stored with a certain amount of bits, that means they only have a certain amount of precision they can have. And again, the float is the single amount of precision, so it has a certain amount of decimal places it can go to, while the double can go twice as many in a sense. Yeah? Okay, hopefully that makes sense. And then bool. Bool is a type where it stores a Boolean type. It can either be 0 or 1, true or false, on and off, whatever you want to call it. And that's what it is. And that's specified to be at least 1 bit. So most compilers will actually make this either a byte or maybe a word size or so on and so forth. Again, don't worry about all these technical terms. You can research them for yourself. It's quite interesting. But that's what they mean. So earlier I talked about you can actually have some kind of qualifiers on these types and get some extra types from them. So I can actually supply short and long long to int. So I can say short int, and I could say it's called like sh if I wanted to. Or long int, and I could call this Frank. Or I could have long int, and I could call this, I don't know, Peter. I'm calling them variables. You can omit the word int from these, because the compiler will understand that these are integers. A short is a short integer, a long is a long integer, and a long is a long integer. The compiler will understand that. The intent of putting these shorts, these longs, and these longs is to provide different lengths for the integers for different practical reasons. So again, an int is normally the size, again as I said, the natural size of a particular machine, while short and long are going to be different sizes. So a short is often, and this is again often, 16 bits. Yeah? And it's specified to be at least 16 bits. A long is typically 32 bits, but in the specification it's specified to be at least 32 bits, and depending on which compiler and even operating system you're on, this will be different. A long is specified to be at least 64 bits. Again, so the more higher these different things is different precision. And by default, long is the highest type you can store from these basic data types. And I'll put int in here. So I'm just going to call this another one. I'm going to call it Tom. Why not? I can call it whatever variable I want. It's my episode. And an int is specified to be at least 16 bits as well. Now, I'll write the typical values in here. So typically, it's going to be 16 bits. An integer is typically either 16 or 32. Long is typically 32. And a long is typically 64. And the reason why I'm saying it's either 16 or 32 is depending on the age of your computer. On modern computers nowadays, an int will be 32 bits. But if you're an old computer or working on maybe some microcontrollers or something, it might be 16. So they're the sizes. As well as the sizes as well, you can also specify if your integer wants to be signed or unsigned. And this can also be applied to the char or any integer, in fact. So if I wrote unsigned int, like so, I'm just going to write it there. This now means that this integer can only hold unsigned numbers, so from 0 to whatever it needs to be. So they'll always be positive or 0. I can also say unsigned short int, and again I can remove the int as well, and that would be an unsigned size, same size as a short but unsigned. I could do an unsigned long and an unsigned long, and these are all positive values. You may be able to guess I could also write signed if I wanted to, a signed int, or a signed short x and whatever, etc. But by default, these types without the signed, these are already signed by default. So you don't have to write signed if you want. And in fact, there is also one other little thing you can do is with unsigned, you can actually omit the int again, and by default, this is going to be an unsigned int. Some people like that convention, some people don't. I don't particularly like it myself. If I'm going to write unsigned int, I'm going to write unsigned int. But again, it's up to you. Be consistent is my short answer. And the last thing I also said is that you can also apply this unsigned and signed bit to chars. So if a char by default is storing a character, you can turn it into kind of an integer in a sense. So if a char is 8 bits, then an unsigned char can store numbers from 0 to 255. So an unsigned char, yeah? But if you have a signed char, you can store numbers from -128 to 127 on a 2's complement machine. If it's a 1's complement machine, then it's -127 to 127, yeah? Don't worry about what I'm talking about with 1's complement and 2's complement. If you want to research that up, you can. This is teach you how the computers do arithmetic in machines. But most modern computers do 2's complement. So that's what an unsigned and signed char is. Now, what about a regular char? You can treat that as actually an integer. But depending on the compiler, and depending on the machine you're on, whatever, it doesn't actually have to specify if this is signed or unsigned. So if you want an unsigned byte, use an unsigned char. Do not write char, because it might be signed, it might be unsigned. You don't know. So there we go. So the next thing we want to write is about longs and doubles. So longs and floats. So we can do a long double. So you can actually add that as well. So a long double is an extended precision floating point number. Now, this isn't specified by the spec. All it means is it has to be equal to or bigger than a double. On many computers, it could be 80 bits, or it could be 128 bits. It depends on what your computer supports, so I would go check that out. I don't particularly ever use a long double myself, but some people do, and there are some uses. But again, with your floating point numbers, you cannot put unsigned or signed on them. Every single floating point number is signed. They have to be signed. So there you go. They are the basic data types in C. So we have the chars, ints, floats, doubles, and bools. And then we've learned about the shorts, the longs, and longs. Learned about the unsigned variants of them and the signed variants. We learned that we can also apply them to a char, so we can get a byte-sized integer. And also can learn about a long int, a long double. So a long double is a extended precision floating point number. So thank you for watching and stay tuned for the next episode.